Okay, so let's go. This video is just a little tutorial about a very specific part of the book of Monads, and it's in the chapter 1. And the author describes a relabeling function. So it's a function that just traverses a tree and adds an index to each leaf of the tree. So it goes from left to right, and we gave it a tree. So I've got a test tree to describe that. So I've got a test tree that has no index, and after the relabeling, it will end up with an index. So just below it's just a GHCI with this file loaded, and the first line is the monadic version that the author came up with, ends up with, and the other one is the original, the starting point. And so it's it goes very fast in the book and just says, okay, you use order function to replicate this mechanism, and you end up with that. So so in the book you start up with this function and end up with all these things. And then there we will see how we can achieve that step by step, to just understand why we do this and how it works. So just briefly how the function works. We've got a tree, we've got, so the first one is the tree we have to relabel, it has no label there. The start index, the current index, and it will output the relabel tree. So I just changed just a little detail compared to the books. So it's an int there in the book. And just not to confuse that with the index, I just put a string and just use the show function to convert the index to a string. So how it works, so it starts by pattern matching on the tree constructor. If it's a leaf, it will actually be indexed, and it receives the current index and label the leaf with this index and increment the index. And if it's a node, so it still has the current index, and it will recurse on the left tree with the index it started with. As an output, it will have we will have the relabeled left tree and the index after the relabeling of the left tree, and then we'll relabel the right tree with the index we ended up with on the left side, and we have the indexed right tree, the new index after the right relabeling, and we'll output this node, which is an indexed node with the true indexed trees and the current index, and we recurse and traverse all the tree like that. And as we can see, so I can just be sure it works. So yeah, it works. So this function there is this one, and I will work on this one and try to keep this second line the same as the first one. So here we go. So the first thing we'd like to do is to hide the details, the implementation details kind of this function. So we'd like to take a tree, a non-labeled tree, and output another type with the labeled tree. So just to put an emphasis on this, we can just use the lambda notation. Yeah, so we reload, we test, yeah, nothing broke. So now what's our problem? The problem that we can have is to use the wrong index, or use an index at the wrong place. So for instance, we could just forget to use the index of the left tree when we start indexing the right tree. So if I reload and test, we can see that it doesn't work anymore, and nothing prevents us in the type checker to do this kind of mistake. So actually we would like to have a function that takes relabel functions and compose them together. The thing is that we can't just compose the relabel function as is, because simply the output type of the relabel function is not the same as the input type, so we can just feed relabel in a relabel. So we'll have to define an higher order function that will do this job for us, and that's what the authors say, to abstract basically the mechanism of taking this out, give it there, and all this stuff. So let's define a function that could work this way. So let's call it chain. Okay, so the chain function is a function that will be used to make the composition for us. So it will take kind of the relabel output type and use that as input. Also, because we want to be able to chain the chain functions, it will output the same type. So I will just add brackets. So it's yep. Okay, and the chain function currently has a f function, and the output is undefined. So the f is actually the same thing as this, and we want to end up with this. So I just can do that, and it type checks, but we can feel that it's not the thing we want to do. First thing is that we want to compose the two relabel functions. So the idea will be the chain function as input the relabel function type, or at least the part that interests us. So we can just add this there, and so we've got the first relabel. The G will be the second relabel, and will output this. So since this thing is the same type as this one, they can be fed inside the output of the chain function can be chained inside the input of another one. So we can just compose them. So it's cool. The problem. So maybe we can just apply. So we take this one, then this one, and giving us. So we have to mimic the way the relabel function works. So we take the current index and do the relabeling there. So we can do something like that, and it will most likely type check. But yeah, and it's not used, so we can see that it doesn't do, but it doesn't do the right thing. But we can feel that the G function is just not used, so it will just won't work. So maybe we can do the same thing as there, and so let's do something like that. We just do the same one, I1 in. Can do this. So yeah, we can see that obviously just applying the f function won't lead to the good result. We have to use the g function in a way, so we can just do that. But doing so, we'll just use the relabel with the what will be the R tree, but we just discarded this. We didn't use that, so we can just maybe use it there. But we still haven't used the left tree. So just a quick thing about argument position and the concept of negative and positive position. So basically, negative positions are what had to be given to the function so it works, and positive arguments are positive positions. Is what will be outputted somehow. And The thing is, so we can easily say, okay, this part is negative, and it will output this, or this one is negative also, and it will output this. The thing is that when functions themselves are in arguments in negative positions, it's kind of switched. And for instance, this int, you don't have to provide it. It's in a positive position. It has to be provided in a way, but when you write the G function, you don't have to provide this int. It's just there to be bound. And we can do the same thing there and say, okay, I need the left tree. So I will just add an argument, so it will be in a positive position, so it will have to be fed, provided in a way somehow, but not from the color side. So I can just say, okay, give me this, and it will be what you like, the tree. Basically, it will be the tree there that will put there, so it can be used by the G function. And actually, maybe we can just try to give the L prime, and yeah, it type checks. So how this function will work? So we'll have to feed it with two functions, and then it's the same mechanism as relabel. It will take an int, apply the f function on this int, end up with what was the left tree in our example and the new index, and then this tree will be fed there, and so it will be the new tree for the new relabeling, and the current index there, and apply the G function. So let's see how it can work. So using this G function, we don't need that anymore, and we'll use chain. So we'll first like to use the relabel L. I will just fix the indentation, and we don't want that. So it's the first argument, it's this one. Then we need a function that takes a tree and then takes an int and outputs this stuff. So that's actually, so we can use, we can just say, okay, bind it this way, because we don't have to actually provide it, we just have to define a function that takes this tree, and then do what you want. So maybe we can use the, I think I can just do something like, let's just do something that is not what we want, but that will type check quickly, and we'll just do something like that. I think it can type check, so R doesn't exist yet there, and this is the same height as this one because we output the whole function. And actually we can see that the yellow thing is just hling that complains, but it type checks, and if we have a look, it clearly doesn't behave how we would like to, because we just didn't use the error relabeling just at all, but we already have something like that checks. And as we say, the output of the chain function can be fed into the chain function, because this thing and this thing are the same. So maybe there we can just add something like chain relabel, this time the air one, and just take our tree there, and oops. Okay, so yep, it doesn't do exactly what we want. Maybe, yeah, actually it can't, because we like to do this. And yeah, here we go. We've got the same result. So now, so it was the hardest part. Now it's just renaming stuff and all this thing. We've got all we want. So yeah, we can just say, okay, I will put this outside the function, so the chain one. Okay. So I don't know if the formatter will be clever enough. No. Okay, so we've got our chain function that is, well, as you can see, it's the same thing as the next function. So so what can we do? We can see that this stuff can be found there and there also. So let's use a type alias to just abstract this thing. So let's call it labeler. I don't know if there's double L in, I guess so, there's double L in English, and it will be this. And it equals this, so I can say, okay, it takes a labeler A, that's a tree, blah blah blah, outputs labeler A, and there, oops, we still have a labeler A, and looks like it still works. Yep. Okay. Maybe we can just, so now we kept the same A that what it was originally meaning, but maybe this this pair, or at least this tree, the relabel tree could be our A. So I can just remove that and say, okay, the single thing I have to fix is that now no, here it's not, the A is this type. So yeah, so still works. And yeah, and if we want, we can say that, okay, this one will be a labeler A. And what's the problem there? Doesn't type checks. It's a leaf. Yeah, it's not just A, it's so we have to provide the type. So it's the A, what is the A? It's a tree A string. Okay, it works. So we can see there that the B type is used. So there's two main reasons for that. The first one is, okay, it adds polymorphism and say, okay, if you are able to provide a function that goes from A to with counter B, okay, so it just adds a new type if you want to, and if the B type is the same type of the A, it's fine also. So it just adds polymorphism without messing anything. But there's another more important, I mean, it's not more important, but there's another reason to do so, and it's, as you can see, I can just output that as I did before, and it actually type checks. So the F is a labeler A, and it takes an int and outputs new labeler A. So yeah, okay, fine. And what happens if I put a B there? Actually, it won't work. It doesn't work anymore because what it says is basically that yeah, you output an A and I want a B. So it actually forces us to use this this function. So we can see that there. think I missed something with the indentation. And what did I do wrong? I think it's just a bracket somewhere. Labeler A, labeler B. What does it say? Parse error, yeah. Okay, now it's happy again, and we didn't change anything. So, and there we enforce the use of this G function there. So it's a good thing, is just we can't write anything else. Okay, so using that, we can just use infix notation for the chain. So we'll just put there between there, put it there. It still works, and we can just remove all these brackets. I think this one will be needed and this one not anymore. So here we go, we can have something like that, and yeah, let's do something like that. And then it just, yeah, now it's very easy. Let's define the same thing as the pure, and I won't spend too long on this one because it's quite easy. Let's call it lift, and let's put labeler A, and we can just, so the lift just take an A and output, so it just creates pair. So that's basically what's happening there. So I can just use lift there, and since the I will be provided, so yeah, I think that's done. Well, let's refresh and test, and yeah, we've got the same function. So same thing, we can see that the labeler and the and the with counter are the same types. The chain function is the exact same as the next one. The pure and lift are the same, and our new relabel is the exact same one. So yeah, so hope this helps. It took me a bit of time to just figure out all this, and I just wanted to share it. So yeah, have a nice day. Bye.